Okay, I'm only going to briefly mention this because the math behind this gets ugly quickly. And these are second-order differential systems. But the idea behind parasitic effects are that no component behaves ideally. Okay? Your inductances have a small amount of resistance in them. They also have a small amount of capacitance in them, believe it or not. Capacitors have a small amount of inductance in them. They come from eddy currents that form in the plates. Resistors are just resistors, though. They actually don't have any parasitic effects that we can measure. But both inductors and capacitors, they do behave non-ideally. So for a capacitor, what you have is you have the series resistance, which is the resistance of how much resistance there is to put electrons into a capacitor. You then have the capacitance that I believe breaks out into, oh, this is drawn in the book. I don't have my book present. Hold on a second. Non-parasitic effects. Oh. Oh, I don't have the picture for the one for the capacitor. But there is a small amount of resistance that is allowed to pass through your capacitor, which is, it's modeled as the amount of charges that are able to travel through the dielectric. And that's what this stands for. This stands for the amount of resistance that it takes to charge the plates. And then I believe there's actually an inductor in series too up here. Just gonna draw it real tiny. Okay. For an inductor, there is, again, some resistance that comes from just the wire naturally. There is a resistance that exists that comes from heat loss through the core. The ferritic core has some heat loss. It does heat up. And that's represented by Rp. You have some capacitance, which is represented by the electric field that is generated. And then, of course, you have your inductance. So these are much more complex systems than we're going to be handling right now. And even when we learn how to handle these systems, we're still not going to go back and try to figure this out. But in a real system, there is some amount of current that does travel through the capacitor. There is some amount of current that does travel through your inductor that does not go through the coils, but actually goes through the ferritic core. Okay? There is some amount of capacitance that exists in an inductor because there's an electric field that gets generated. Okay? There's some amount of inductance in a capacitor because there's some amount of magnetic field that gets created due to eddy currents in the plates. So these are not perfect components. Now, the LS value is very small. RS and RP, they are very, very, very small values. Okay, actually, our RP is very large, RS is very small. Similarly, down here, RP is very large, RS is very small, and the capacitance is also very small. for an inductor. They're not usually noticeable. But if you take these models, you can model just about anything that stores any amount of charge or generates any amount of magnetic energy. Okay, everything can be modeled with these two. All right, well, that's all I had. You have a homework assignment due tonight. You have a quiz due tonight. You have 2 homework assignments due tonight. No, 1 homework assignment due tonight. You do not have a reading due tonight.
We have a reading, quiz, homework.
Reading is due tonight? I thought I